Hello again, everyone, and thank you for joining our webinar. This is our fourth series of webinar, and we're going to cover the installation, wiring, and controls for the STEP Warmfloor. And I want to, you can certainly go back and look at the rest of the webinars that we have on our website, and well, hopefully we can, you've learned from how to sell the product on reliability, energy efficiency, simplicity, and safety, how to know about the different applications that are out there, and what the importance of floor coverings and insulation have and how it can affect on performance. So raise your hands out there if you've picked up on this and learned. Okay, I see a few of them out there. Phil, you can put your hand down now. But thank you again for joining. We really appreciate you taking the time here today. And we feel this portion of the webinar is something that you can easily grasp, especially if you're an electrician, because it gets into the nitty-gritty work of actually putting the system in. So before we want to begin is you want to really plan your STEP Warmfloor installation, and each one of these quotes that you get is going to include a worksheet and layout diagram. It's important to look at each one of those and study it and learn what is there for you to follow. If you follow the worksheet and layouts, you're going to have a successful installation every time. Understand, too, that there's limitations on secondary wire lengths, and especially sometimes electricians get mixed signals on that because they often are familiar with line voltage, high voltage systems, but these low voltage systems, you got to be careful on the low voltage drop. Another thing to do when you plan your installations, understand where you want to put the transformer and thermostats. It's important to get that transformer location closer to the load or to the floor heating element. So think about that in your process, and then last you want to determine what type of control or thermostat you want to regulate the temperature with. So with that, we want to ensure that the materials that were used in the installation are compatible with STEP Warmfloor. We've covered some of those things with insulation on tile applications, that with insulation, and what to use and what not to use. So look back on the previous webinars for that information. You also want to follow your local codes and obviously the manufacturer's instructions, and use the components recommended by the manufacturer. So here's what we're looking at in the components, and we haven't really covered these in detail, but basically these are the three components that are going to make this system operational. You have your thermostat, your power supply, which is the transformer, so it's a step-down transformer, and then obviously the heating element. So we're going to begin with the thermostats, and basically there's two low-voltage thermostats that work with the STEP Warmfloor system. The one on your left is a TH thermostat, and basically it's a non-programmable. It can capable of doing air or floor sensing temperatures or both. So that's going to be your standard thermostat, very easy to understand, easy to read, easy to use. And on the other side is the programmable thermostat that can also do air and floor temperature sensing. That's going to be easy to program, but it's going to give you a little bit more features with like it's going to have the clock on it so you can see the time of day, and a little bit more availability of turning the system on and off when you're not there. So it's something if you're in a cabin that you may want to shut off completely when you're not using it. Otherwise, if you're using your system on a day-to-day basis, I recommend the TH thermostat there. STEP Warmfloor gains its efficiency by staying on. So think of it, again, of running on the freeway. The more we run on the freeway, the better gas mileage. The more we run and let the system operate and self-regulate on its own is going to save energy in the long run. So this thermostat also has a capability of tying in with a sensor. And this temperature sensor is going to help regulate and really fine-tune the system. And you're going to put this in where you want to control floor temperatures separated from air temperatures. You might have a competing heating system that you don't want the thermostat to trip off. So the sensor acts as a way to really dial in control. Now this temperature sensor is not a high limit sensor that you may see in a cable system. Cable systems typically have a high limit sensor to prevent it from high limiting. But this is just a temperature sensing that's going to actually communicate to the thermostat to really dial in temperature. Where you're going to put this is right between the heating elements. So you have the elements there, and the sensor basically goes in between the elements, and obviously you're going to be covering it with any type of floor covering, tile, carpet, wood. And it's just a note too on the installation side of this sensor is that you typically would wire it in conduit and place it between the heating elements. The conduit is just going to protect it from any abrasions or anything as you snake it down through the floor. So how this all ties into the transformer is very important, and this is probably new to a lot of you, but wanted to show you that the transformer is where we're going to tie these thermostats into. And I'm going to blow this picture up a little bit for you. Hopefully this all works. And here you're going to see the thermostat, and ignore really the color wires. It's more important that you get the connections right from one end to the other end of the element. So I drag my mouse here. Basically you got a common trigger and a 24 volts. So you basically are going to tie that same colored wire to the common trigger at 24 volts. Now this board is located on the top side of the transformer. Very easily, you take and slide the cover off, you run your low voltage wires through, and I'll cover that in a little bit. On the right hand side is we're going to be able to tie on additional transformers downstream of the initial transformer. So basically you can hook up 20 transformers off a single thermostat. So if a large commercial application, one thermostat, one zone can handle 20 transformers downstream. So the control options too is not just limited to low voltage thermostats. There's also line voltage thermostats or line voltage regulators that are available. The one on the top right is the line voltage time controller. It's called a micro program controller, and basically it's just an on-off cycle that you can set your runtime on and basically let it operate on itself. So the on time, more on time, you set it to a higher number. Lower off time, you set it to a lower number. So you just let it regulate on its own. So most of the applications you're going to see are going to be small areas like bathrooms. Another application for control would be the on-off switch, just a simple switch. And this is basically how I utilize our product in my family's bathroom there, is that the switch is just turn it on in the fall and we shut it off in the spring. So we let the element just self-regulate on its own, and it works fantastic that way. So benefits of the power supply, and these power supplies are going to be designed to install and fit right into a wall cavity. They're perfected for precise regulation and control of the STEP Warmfloor heating element. Yes, you could use another transformer from ABC Power Supply Company, but this system is going to work in tune directly with the STEP Warmfloor to get many years of operation out of the transformer. So really it's a 10-year warranty, it's ETL approved, and the STEP Warmfloor Electroplastics really has refined this product and the power supply as a trusted system that is going to work for many years to come. Here kind of gives you a little snapshot of it. The voltage is in 120 volts, 208 volts, typically for commercial applications, or 240 volts. And the secondary voltage is always going to be 24 volts AC. And inside the transformer, and I got some pictures later on that I'll show you, that has the circuit breakers on the primary and secondary for protection of the heating elements. Here kind of gives you a little snapshot of the size, and this might be difficult for some of you to pick up and read, but all the transformers, and I'll kind of highlight here, are all 3.5 inches in height, or in depth I should say, and the width on them is 6.9 inches. So every one of these transformers is going to have this configuration into it. So it's not that deep. It changes in height based on its size. You can see from a 250 to a 500 watt transformer all the way up to a 1500 watt transformer graduates in size and height. So we can see a 1500 watt transformer is capable is 24 inches in height. So it gets pretty tall out there. Some people might feel it's a little large, but there's places to put this, which I'll cover too. Keep in mind too, the weight is 39 pounds. So it's kind of a heavy thing, but it's doing a lot of work. It's taken that voltage from a primary 120 or 240 volt and dropping it down to the low voltage safe operating voltage. I also want to note that even though this is the EPI LXR power supply series that are regulated, and that's what the R stands up for, but there's also non-regulated power supplies that you can use the microprogram with and or a switch. So keep in mind that it's going to lower the cost a little bit from the regulated transformers. So you got some flexibility of transformers based on the application. Here's kind of gives you a little bit of a snapshot of the toroidal coils that are inside each of the transformers. And basically they've taken a ring-shaped core, which really minimizes mechanical hum and runs cooler. The older power supplies that are out there ran warm, and customers are a little bit concerned about this, but in fact with this new design we have not received any complaints from the customer regarding temperature or touching the transformer housing. So very nice design. Everything is extruded aluminum that helps keep things cool. So the coils are 100% efficient, and for those with concern of magnetic fields, it offers a very low exterior magnetic field for EMF readings. So when we look at the worksheets, and I'm going to dive into this a little bit, but I just highlighted the portion of this because it's important to know what the ampacity of that transformer is going to be. And this particular account was an EPI LX 1500 transformer. It was at 240 volts. But it's important for the electrician to understand, or you as the designer, anybody who's wiring the line voltage to it, that here's the power supply needed. So this is 5.2 amps at 240 volts. So this area is 444 square feet of tile, all operated off of 5.2 amps. So it's phenomenal. It's very low energy draw that customers can expect and realize with energy savings. So the transformer installation is pretty basic and very easy. You would first locate your position, and you would, for the positioning hole there, you would rest it on a nail, head, or screw, and that basically will give your position to put a level on it and then screw it to whatever backer board that you have, or cement, but keep in mind too that there is bumpers that come with every one of these transformers, and that helps isolate the transformer. It helps create a little gap on the back side of the transformer for air to go on the back side and keep the system and transformer cool. Also, once you remove the nail, that acts as an entry point for your low voltage thermostat wire to tie into the top board. So very ingenious installation or transformer, how they designed this. Incidentally too, that the bumpers reduce vibrations too, so that's a nice thing, because transformers can make a little bit of a resonant sound, especially if you put them to a surface that can have slight movement. So use the bumpers to help minimize noise. The bottom side of the transformer then has the capability of circuit protection, and you would basically wire the service panel 120, 240 volts. You have a disconnect switch that is optional. In fact, many codes and regulations, if you're within sight of the electrical panel, this switch is not recommended or needed. But you get the little idea that everything is ran through here for the voltage. And then on the other side, and this might be a poor picture, but you can see the transformer circuit breakers. On the far left, you have the main circuit supply voltage, the line voltage protection, and on the right, you have, in this case, you'd have 3 circuit protectors, breakers. They're all 25 amp, and those are going to protect the low voltage side that the transformer and the elements are tied into here. So the nice thing about this configuration and this board that it's on is that you'll have little indicator lights that will tell you when the system is active. So very nice way, and these are easy plug-in and resettable breakers. Very nice system design. So where are we going to put these? You know, transformers is probably the Achilles heel of the product, in fact, because we have to have a place to take that line voltage power, drop it down to low voltage, 24 volts, but have it somewhat close to the location or the room or rooms that the heating element is installed. So as closer to the heating element as possible is what you want to do, is plan. Areas with good ventilation is important. So maybe design in front of the stairs, utility room, in the attics. Number of ways you can put it in. And design it for vertical mounting only. Everything you have to has an arrow on the transformer, and so abide by the manufacturer's installation instructions and mount that in a vertical configuration only. And on this side, you can see how they've taken this and put it right behind the. This happens to be a family room, or there's 2 bedrooms, and it was the end of the hallway, and they just faced it with a ventilated cabinet. So it was a nice little design. So you can put it in closets is another way to put it. Hide it. You've got closets out there. You can put it under the stairs. A number of ways that you can. You can go underneath and put it recessed cabinets. This is a nice configuration. It may not be aesthetically pleasing for some, but if it's in a closet, it keeps hands and fingers away from it, but also keeps everything nice and ventilated. So before you begin, you really need to understand the system in more detail, and I can't stress that enough, because the first time you're going to look at the product, you're kind of go, wow, you know, I got all this element, I got this paperwork, and how do I put this all together? Trust me, if you can read and look and understand the instructions that the worksheet follows, you got a wealth of information from the Heat My Floors staff here. You got the manufacturer is always ready to offer their installation advice, but understand it a little bit more, understand the worksheets. If you do that, you're going to be able to use this system and use it very quickly and install it quickly. Your speed, well, that'll come with experience over time. It's kind of like riding a bike. First time you ride your bike, you're going to get a little wiggle, wobble all over there. By the time you do your second or third installation, you're going to become a pro with it. So also, understand the watts per lineal foot relationship, and the more you understand that, the more you'll be able to design these systems on the fly. In fact, I talked with a gentleman today up in northern Minnesota that put a system in, and he says, after I got one room done, I was really picking up how the system is designed and how much I can load the transformer's connections. And so he had a 7.8 watt under, there's about just under 1,000 feet of element. And he had 7.8 watt element underneath hardwood floor. And he says it went simple. It was a very easy installation. Some of the tools you're going to be required, hey, you got some of these hanging around in your shop already. You've got anywhere from utility knife to scissors. It's important to have a wire strippers. You may need to staple the product down if it's a wood subfloor. You may need to glue it down if it's other substrates. The key component too is the voltmeter. We want to make sure that when you're making these connections, that before you wire them to the transformer, that you have continuity there. The key part is continuity, is that today it's an ohm reading of, let's say it's 5 ohms. And what will really throw you off, especially when you're doing this when you just laid the element, you have 5 ohms, for example. But when the element gets covered up and the room becomes warmer, the resistance changes. So don't let that throw you off. Just ensure that you have continuity there. And the screwdriver obviously is going to come handy. But the main tool, and I can't stress this enough, this is the crimp tool that's required in all STEP Warmfloor applications. It's very important that you utilize this crimp tool for warranty purposes and to ensure long life, to ensure that crimp connection is secure. So let's look at kind of a job, and this is a scale model of a kitchen area that happened to be with a hardwood floor going over the top of it. But I just want to give you an idea, and you've seen this on the other webinars we've had. But here's basically the STEP Warmfloor element laid down. Now this gives you a good roadmap to follow of how these elements are going to be interconnected. So study this. I study this when I look and I train contractors on the job, and I tell them this is where you got to study and understand where your relationship with the transformers are going to go. In fact, the transformers in this job, if I remember right, were right in this location. So it's really close to the load. Now, if the transformer cannot be close to the heating element, there is ways to work around with larger conductor sizes or using terminal blocks, and I'll cover that here soon. So study the layout of it. With that layout in these worksheets, you'll get an idea of how they interconnect. And here is what I feel is one of the most important things. I utilize this sheet.
Hi everybody, we had a small technical difficulty, so Dennis will be back on shortly.
Sorry about that, everyone. For some reason the power supply just cut down on us, so even here in a power utility company we do have power outages. So we're going to work around that. I apologize for that inconvenience. So what I'm getting at here is this area of the worksheet is basically a wiring schematic to follow. And this is going to be difficult to see at first glance on your computer, but I'm not going to get into too much details, but utilize this to wire it, and it's going to work perfect. And it's going to be ease in wiring. I'm going to blow this section up with elements 1, 2, and 3. So basically what it's telling us is that we're going in on element number 1, connections, and then they're daisy chained. Everything's wired in parallel. There's no series wiring with the STEP Warmfloor element. Everything is in parallel. So we're going to come and wire into one element and come out of that element and connect into here. So basically we have these two elements wired in parallel, daisy chain configuration, which adds up to what looks about 31 feet. The key here is what I've circled is that these two elements can only be 15 feet away from the transformer. Now again, if that needs to be, the transformer can only be, let's say, 20 feet away, then we may need to look at terminal blocks. Or we could separate these elements and home run them separately and tie them into a terminal block. So that's a lot maybe for you to, to absorb in this webinar, but there's ways around that you can individually wire the elements back to the transformer. And first you'd tie them into a terminal block and then to the transformer, or you'd wire them in a daisy configuration. But follow that wiring schematic and you'll have an easy time on your first go around with the product. Each of the products has a required set of wires and connectors to comply with ANSI or UL approval. And we can't stress enough, too, the extension wire or the low voltage wire that leads from the power slide to the elements, that it has to be stranded tin copper. Remember that the element is a bus braid is aluminum. So we don't want two unlike metals touching. So we definitely don't want stranded copper on stranded aluminum, or else we're going to have a galvanic reaction that is going to create a loose connection over time. So keep it with stranded tin copper. Every one of the jobs STEP Warmfloor sells, Heat My Floors provides to you, will have the stranded tin copper. Also, the connector tape and connector tin copper crimp connectors, boy, that's a lot to say, and the sealant tape comes with every job as well. So everything is out there for the job, so you one-stop shop. You don't have to go out and search for these items anywhere else. And we covered the crimp connector, and that is a necessity to make sure you got these connections tight. Also, the crimp tool can be returned. Basically, it's a rental that you can return later. But if you're a contractor, you're going to have multiple jobs. So I recommend having one crimp tool, if not more than one, especially on large applications where you have a couple installers on the floor. That way you can really fly and make these connections. So this kind of gives you a little idea, and I'm going to show you a video that's going to give us a little bit more in depth on this. But basically, you're going to take the element on the corner, and I always kind of fix the element down and leave about a foot or foot and a half of it not secured to the subfloor. So I staple up, leave about a foot and a half open, and then I would either cut it with the scissors, but if you get really good at it, and you'll find that using a utility knife to score the plastic away here will help you take the plastic off and expose the bus braid. Keep in mind, though, as a note for installing, is that when you take this, make sure when you pull the plastic off here, you don't pull it down the element. You pull it away from you. Always pull the plastic away. So you're going to use some recommended crimps that are going to go and sleeve onto this bus braid, and then the extension low voltage wires come to there, and then you crimp. And I'll touch on this a little bit better video. The sealant tape is then used at the end to make sure that oxidation definitely is not going to happen, but no air or water is going to get into this that can degrade that connection. I should say moisture, but moisture and air not going to get in there. That connection is going to last for many, many, many years. Also, notice too on the bottom page or bottom slide here is that we have black and white wires. So we got different polarities are used in black and white conductors. Kind of gives you an idea, and this is actually at my home, so we got a nice picture of how we 45'd, or actually about a 1 inch down or so from the element, and just scored it and exposed the bus braid. That leaves you about a tail of about an inch long, should be sufficient enough to make that crimp connection on there. The next slide here is going to show you that connection there is complete with the wires running up, and then on the other side shows you the tape. One thing I want to point out is on this slide is that the tape there is on the top. I'm trying to get my mouse back. Here we go. Is that tape is not here. It's not. Tape is used to help seal out this connection, so no moisture can enter along the path along the wire. You want to make sure you press and seal out any of that air out of it. And see how nice and flat it is? Some guys will even take the crimp tool and crimp it again to keep it even more flat. So that's going to help. It's no use putting putting a sealant tape down here, so you don't have to use that much of it. Typically about 1.5 inches would be suffice to cover that connection. So use this as a reference. This is a perfect example to show you how to properly seal it. So securing the element. Securing the element is going to be done a number of ways. You're going to secure it with staples, nails, probably every 2 feet. You want to make sure you keep it nice and flat. That's definitely with wood subfloors. If you got a system with like our Cerazorb product, you can use hot melt glue, very limited amount, about a quarter size every 2 feet, and just put a little dollop on there just to hold the element down and prevent it from shifting. That way you're, if it's a laminate wood floor, hardwood floor, everything's staying in place and the element isn't shifting and touching. Otherwise, you'd use securing the element by thin set for tile applications or self-levelers is another way to secure it down. But a lot of times it's going to be used staples or nails. I have a little story. We did it was a training session out in Wisconsin, and I went out and didn't have a staple on me, and I was hoping the contractor did. Well, he had a hammer stapler. Well, we hammer stapled it down, and the homeowner came out really concerned that we ruined her radiant floor heating system because we nailed through it. Well, I had to assure her that it worked fine, and we did fire it up, and she was just amazed that we could nail through it that many times without having any adverse effects on the heating element. So it's a nice little story that I like to share that kind of gets people surprised that, oh, you can nail a staple through the product. Wonderful. Okay, here's going to give you a video. I'm going to run it for about 2 minutes and 30 seconds. There's no voice, so I'm going to voice over it. And so no sound, I should say. But hopefully this is all go. We haven't been able to, I'm sorry, to check that portion out. But here we are, laying the elements. And everything's cut to size. Now, the customer or the contractor could have cut these in advance. But this is a small application, so you can cut it on the fly, have the element. There we go, staple it down. Now notice how he's staying away from the outside bus braids that are on the outside edge. But here's they're going to keep it nice and flat. You could also use a tape, a poly tape, that could hold that down in lieu of staples. So I think that's basically what this installation video is showing, is that you have other choices besides staples. Here we're cutting around the ductwork, and that's a powerful picture to show that those elements right there are not going to work in that location, but it's going to continue to work everywhere else. Here he's going to make the connections, and he's got a big scissors there that he's going to make and strip the wires off. So he's down about 1 inch from each side, and notice how he pulls it away from himself. He doesn't want that wire to pull in like a zipper. It's always pulled away from the heating element. So he notches it in right there. He does his little diagonal cut, and voila, he's got a nice connection just like that. You see it in real time there. The next thing, he's going to show us the way of a utility knife. A utility knife is a nice way to do it too. A lot of guys will do it this way because it's just fast. You don't have to pick up the scissors, spread the scissors. You can just make your score connections and strip the wires. So the first 2 connections you're going to do, this is going to be slow. By the time you work in that 3rd or 4th element, you're going to be a pro. Here he's used a wiring strippers, and then he's going to, looks like he's going to take the other one on the white. It's like I'm calling a football game, play-by-play. So this is fun. And he's now going to spread out, he's kind of fanning out the strands of wire, and then he's going to insert the crimp across in the bus braid. So there's a sleeve crimp, and then insert where you already fanned out the element. He's fanning that out to have a wider contact against that sleeve crimp, that crimp connection. And there he comes with the crimp. Now that crimp's going to be pretty hard to squeeze at once, but by the time you get your 4th or 5th element connected, it's going to be easier to squeeze. Here's about 1.5 inches of sealant tape. Easy enough. He's going to take that, peel it off, go to the connection. Notice he's riding on it's on the top, and he's going to squeeze out the air that's in there, and you got a nice flat connection. So that hopefully gives you a little bit of an understanding of how easy the system is to install. And you finally finish it off, whatever floor covering you put on top. And now you got a system for a lifetime. So very, very powerful tool of watching, and we hope to bring this type of video things to you in future webinars and or YouTube videos. So the wiring options, there's key components, and given our time here with only 1 hour to spend with you, we can't drill down into everything. But this kind of gives you a little idea of the transformer and wiring, and every one of the crimp C&T connector packages has this diagram in it. The important thing is that the elements can be wired directly to the interface board on the transformer, just like we have here. So basically, we have a daisy chain or parallel configuration of elements that are then wired to the transformer. So on a 500 watt transformer, this you could put 225 watts on one side of the connection and 225 watts on the other. So a total of 450 watts here, 450 here, 450 here collectively. So this is a 1500 watt transformer because we have 3 secondary breakers. Here shows the terminal block. I think I got a slide here a little bit later that I showed, but the terminal block is where you can basically think of it as a manifold, an electric manifold that you can header up a series of elements together and then only run 2 wires back to the transformer. And so here we got a number of elements that are maybe independently wired to the terminal block, but then only 2 wires back. Here's a bigger picture to kind of give you a better understanding of it. We have a thermostat here that's controlling. This is on the top board. We are connecting down to downstream transformers if we're running off the same thermostat. On the bottom side of the transformer, you have a switch to interrupt the power to it for service. You have the power supply with the breaker. You also have the secondary low voltage breakers. This gives you a better snapshot of how these elements are daisy chained together and then ran up to it. So here we have 1A and 2A. So collectively, we can put 450 watts here, 225 here, 225 watts on 2A. And that's going to carry on with 1B, 2B, 1C, and 2C. And this is all going to be spelled out real easily in your worksheets. That's why it's important to reiterate the importance of understanding the worksheets before you begin to install. So here it gives you a nice little snapshot of the transformers, and this happens to be a wood floor application. And what this contractor did was mount these transformers in advance of the installation. He did this at his shop, so all he had to do was go out and place the board onto the wall, screw it down, and then make the wiring connections. You can see they've got here's a cover, and then you got the cover slid up here to expose the transformers, the toroidal coils, and then you have the wiring board on the bottom side of it. It's important to understand that polarity of the heating elements, the layout of it, is that you have these wires, and this is somewhat difficult to see, but I'll step you through it too, is that you have basically a white, black, black, white. Notice that the phases or the same polarity are never, we don't have a black, white, black, white. So these two phases being black, or the positive, think of it, are close to each other. As well as you got the whites are the negative. Think of that as the battery side, the negative side. They are together. So we have a white, black, black, white, carried back to white, black, and so forth. That way, if there ever anything would happen where these elements would slide, they're never going to touch each other and short out the breaker. So this is a proper way to do it. And here they're showing fail-safe wiring. And I took this out of our webinar because it's just a little difficult to explain over the time that we have together. So, but just this gives you a nice, easy way to wire and figure out the polarity. And here's the terminal block. Now the terminal block is going to be used for long wiring distances between the transformer and the heating elements. And you're going to wire transformer, the terminal block is going to have 10 gauge wire or larger to the terminal block. So this is your electric manifold that then are going to handle all these heating elements. So perhaps these elements were 30 feet away, as opposed to 15 feet away like we showed in the earlier example. So we ran the terminal block closer to the heating elements to avoid voltage drop, but we ran larger gauge wires to minimize that voltage drop. And this will all be spelled out in the installation and wiring guidelines that are in each one of the STEP Warmfloor installations. Fail-safe wiring, I guess I did cover it. I thought I was going to leave it out just to give it time, but it looks like we have a little bit of time yet. And basically fail-safe wiring is to ensure the elements won't short out during the installation, or perhaps if you have a staple-up application between the joists, that you have the elements laid up in there and everything's insulated, and now down the road somebody put a wall up and shot nails to hold the wall up from above. Well, what if one of them hit this location here, as by the flashing X? If that would break, we still have continuity of the wires down below. So any break here, that negative side or that white wire still follows, and I highlighted it in red just to show it a little bit more. So a break here, again, we still have power on the other side of the 24 volts to ensure we have 24 volts all the way through the heating element. So fail-safe wire is good where you're not going to be used in like tile applications, not needed, or self-leveling, but definitely for between the joist applications, and some contractors just have the peace of mind, like on carpet applications too, it's recommended, because now you can have things that are out of your control. This just gives you a fail-safe way of peace of mind, knowing that the system is not going to have its integrity cut by a wire being nailed down through. So one thing you want to make sure too is take pictures when you document your work. Take lots of photos. It's always nice to show a brag book too, but if you got pictures to share, the manufacturer, STEP Warmfloor, Electroplastics, as well as Heat My Floors is surely welcome to see your work out there. And it's amazing what I've seen from guys who just installed this product for the first time, and how nice it looks on the floor, and how they comment how easy it was to put together. It's important to mark the wires with the element numbers. That way when you are configuring to the transformer connections, you know which wires which element is marked with what number. It's also important to complete your warranty forms. Hey, forward them into the manufacturer distributor, and that way we have record of it and can abide by the warranties of the 20-year warranty for the element and 10 years for the transformer. There are also some labels that come in the packet of crimp tools. You want to make sure you apply that to the electrical panel. And the last thing is you just want to enjoy a lifetime of comfort and efficiency for your customer. So those are the things that you want to really document it. And the contractor I talked to in northern Minnesota says, I documented it more than I normally would, but laying 1,000 feet of element in a house, I thought it was important to get everything located. So the next guy, 20 years down the road, 30 years down the road, has a roadmap to follow what he did. I want to thank you for joining our webinar today from our entire Heat My Floors team. And I must say, I didn't do this alone. I want to personally thank Andrea, who is my moderator here, and this is Andrea right here. And I want to thank her personally for setting up. It was a lot of organizing on her part to get this, and very successful webinars that we've done for our first time in our history of Right Hand Up Electric and or Heat My Floors. So we're very proud of our achievements, and also want to recognize our colleagues there that are in the picture, and they're out there working for you, and we're there to serve you and help you design these systems for your customers for many, many years to come. And I must say, too, thank you for all the help and support from our good friends at Electroplastics, Stefan and Monica Ergens and their staff. Without them, Heat My Floors would not have their valuable product for us. So thank you again for participating. I'm going to jump into some questions and answer a few. We got a couple of them out there. And had to show you here. Here's me behind the console. I'm running the controls, and that's basically almost a live shot. So I got a couple questions there, and one of them is, what's next for Heat My Floors for future webinars? Love that question. We're gonna ask of you if you have any suggestions. hey, email them along. Email them tonight. Email them during the, you're going to get a survey after this webinar. Let us know, what do you want us to drill down to? We've already taken all this area of information of features and benefits to applications, from insulation and floor coverings all the way to wiring. So there's a lot of information to throw at you, and we hope you enjoyed it. We hope that you're going to carry this to your customer. You can add this as an add-on revenue for your business. So I think nothing's off the table of future webinars. In fact, Andre and I, we've enjoyed this, and we look forward to doing more, and look forward to really getting down to some of the things that we can talk about a topic. Maybe it's only a half hour versus an hour. So keep those suggestions coming. I love that question. Best one of all the series. And the next question I got is, what sets the temperature limit in the switch only application? And Don Marquette's referring to slide number 12, but basically in the switch application where you're just switching the system on and off like I have in my home, the temperature is set by the heating element. Remember, the heating element is self-regulating. It cannot physically get above 82 degrees in temperature. So as it warms up, due to the ambient air warming up, the element is going to work less. So think of the element as the regulating device too. For bathrooms, it's just something that you're in for such a brief time. Now, if you're like my daughters, well, they're in there for 10, 20, 30 minutes. That might be a way to, it's a little bit different control that way, but we just put a switch on it, let it run, and shut it off. And, working for a power company for 22 years, you pay attention to your electric and energy costs, and I can't say that I've seen that rise in energy from our bathrooms being installed with STEP Warmfloor. It's the comfort that we're enjoying. It was an easy installation. So again, it sets the temperature limit is the element at 82 degrees. That's it for our questions. It was a nice short. We must have got answered a bunch of them throughout the time here. We got a little bit of time, it looks like. I'm can open for any other questions. And what I want to recommend is, if you have future projects that you want quotes on, just make sure you send us an email, send us a fax. Our information is down below. You can certainly go out and go on our website at heatmyfloors.com. And what we're going to do is take these applications that you have and put them to design, and we're going to need to know a schematic drawing, a written diagram of it, and then also it's important for us to know the floor covering. So if you have that information, send that, fax that into us, and we'll get a design done typically within 1 to 3 days or less. So that's going to be a starting point for you, and then you're going to get the quotation, and off of that quotation everything's going to be at a list price. So you would take that quotation, and with the contractors we give you our discount of 20%. So you take a 20% off of that price is going to be your actual cost. But some guys use that worksheets as and the quote sheet as their bid sheet. So little suggestions there to do. Other things, STEP Warmfloor, study that features and benefits thing, and I can't stress enough on learning that side to help sell the product over cable systems or hydronic systems when it comes to new construction. It's many things. I sell it all on that, I call it the LESS principle. I'm not sure why. It's just the acronym that I came up with. I try to remember, but it's based on reliability. The product cannot overheat. It's going to last a lifetime. It's based on energy efficiency. The product is 2.5 times more efficient than cable systems. It's 200 times more efficient than hydronic systems. So those types of things are going to help customers understand energy efficiency over the long term of owning the product. Also, the product STEP Warmfloor is simple to install. And lastly, it's safe. At low voltage power, people are not feeling intimidated by wiring these systems up. In fact, many homeowners wire it very easily, follow the worksheets. So also, then you want to understand the applications that you have out there, that there's a number of them out there that you can gain revenue from. And recently we've had an upsale of staple up applications, or between the joists. And I'm happy to hear that when we get information from our sales reps, is that think of the staple up applications as there's applications in every home that you're walking into. So look around, you just a nice add-on sale to the customer that has a nice tiled floor in a bathroom or a kitchen, but didn't install radiant floor heating, and now they have the coulda, woulda, shouldas that I talked about. So nice ways to bring in revenue to your business. Another question I got is, how realistic is it to use the system for the heat source in a project in cold areas such as England? There's no problem if it can heat in England if it heats here in Minnesota as a sole source. If I get your question right, Richard, if it could heat here in Minnesota as a primary heat source, without question, it can handle any application in England as well. It's all a matter of doing a heat loss for the job, and then designing the heating elements to make sure we meet or exceed the watts or BTUs per square foot that heat loss requires. So there is no limitations, big or small, where STEP Warmfloor cannot be used as a primary heating system. If you may recall on early applications, in the applications webinar, my good friend Tim out there in Spearfish, South Dakota, heated this massive opera house all with the STEP Warmfloor product. And that customer, I think, realized that a return on investment in about 3 years from their original oil heating system. Another example of that might be for a primary heating system is the manufacturer, Electroplastics, located in St. Louis, Missouri. They heat primarily with STEP Warmfloor. And during that applications webinar, you can go back and look at that, but you can see that they're heating that building for only 14 cents a square foot. So yeah, it can heat any source no matter where you are in the country or in the world. So I got a two-part question here from Timothy Kittle. Thanks, Timothy, for joining us tonight. Wouldn't the floor temperature sensor compete with the self-regulating system, or does it control max temp? That's a good question. So I'm going to repeat that. Wouldn't the floor temperature sensor compete with the self-regulating system, or does it control max temperature? Basically, the max temperature is the element. The temperature of the element, in this case, we're going to say it's 7.8 watt element, is 82 degrees. That's the maximum temperature that element can achieve. Basically, the floor sensor helps you dial in the temperature you want, but also doesn't compete with other forced air loads or other heating systems in there that can raise the ambient temperature. If there was other heating systems in there, like a vent that is supplying temperature to the room, now without the floor sensor, the thermostat's going to say, hey, I'm satisfied, I'm going to shut down, but the floor might be cooler. By putting a floor sensor in, now we're going to keep that floor sensor, or that floor temperature, nice and warm, and not let it compete with the forced air. So it really helps you dial in comfort. The second part of Timothy's question is, wouldn't some areas be running hotter than others from self-regulation? You've been listening. You're exactly right. You could have areas that are warmer than others, or some drawing more energy than others is a way to look at it. So a way to visualize this in your mind is if you have the sun dumping into a room and you have a lot of glass, where that sun is entering in and onto the floor, the element is going to automatically self-regulate, and it's going to, the carbon chains of the molecules that are in the product are going to open up and create less current paths. meaning less heat. So the sun is bringing in heat. Why create heat if it's already being produced by passive solar? In the areas of the room where it may be shaded from that sun coming in, and the thermostat, or no thermostat, but in this sense, let's say the thermostat is calling for heat, the element in the shaded areas is going to use less energy, all off of that same strip of element. So that's what makes STEP Warmfloor so unique in comparison to other products out there, is that why create energy that is not needed? So the passive solar gain is going to help save energy on a house. STEP Warmfloor is going to complement it and use less energy. So as that shade goes, or that sun goes away, the element works a little bit more. So it's constantly changing its composition to provide uniform temperature when you walk across that floor. That's one of the comments that we get, is nice, uniform, there's no hot spots created like you see in some cable systems. Got another question here, and they're really flying in, and Anja's here, she's writing them out here for me left and right. But can this system be powered entirely by a solar PV system? Thanks, Richard Young. Okay, I got to say now, I like this question better than the other ones on the webinar, because this is excellent. You're entirely correct. You could design the system to operate all off of a PV system, and they have small systems like that in Antarctica where the PV system, or probably wind, either one of those two systems is supplying the 24 volts that is being stored in a battery, and the battery source power, the two batteries in series at 24 volts is supplying the element power, which then prevents the batteries from freezing. What a unique way to utilize the PV or solar system. But on a larger scale, absolutely. In fact, the manufacturer electroplastics down, and I invite you, you can go down there and take a look at these guys, open arms. You come in there and take their living lab and see the product working. But they got solar PV systems out there that are helping offset the heating energy. And it's hard to believe that a building at 14 cents a square foot can be even lowered, but it certainly can, and that's why this building is one that needs to be recognized by architects out there of how you design a facility, be it manufacturing, office complex, that you can design them to have basically zero use or zero energy use. Great question, Richard. Another one you got is, why do you not recommend installing under cabinets and baths? Basically, not putting it underneath the cabinets is just, it's a waste of money, because you're not heating through the cabinet, you're not walking on the surface. So it's not something that we'd recommend you doing, because you got guys who come in and lay a cabinet over the top of the heating element or over the finished floor, the heating element's underneath, they don't see it. They start nailing, screwing to secure the cabinet down to the subfloor, and now they accidentally penetrated a secondary wire or one of the bus braids on the element. So we recommend not installing under the cabinets, also to save money. And I have one final question, and we're coming up to our time, so I appreciate you guys getting these questions out to us. This has been fun. It's keeping me on my toes too. So Ed Green's got a good question here. How far away from the transformer can a terminal be placed? And I guess that's only, we need to know on the design how far that terminal block, but you could, in a sense, put the terminal block, which acts as electric manifold for the heating elements, you could have that, 50 feet away. But 50 feet, depending on what load is connected to it, how many watts of element are connected to that terminal block, you might need to use 4-conductor wire. Well, that gets a little bit more expensive. Or you bring that transformer closer to minimize that conductor size. So You can go far away, but there is some limitations. It's not that you can put it on the other end of a football field and expect it to provide 24 volts. That might be an extreme example, but look at when you get a design done, look at the worksheets, and if it cannot follow within the parameters of that voltage drop or that distance from the transformer to the elements, let us know that. And we'll work with you on maybe terminal blocks might be needed and or maybe heavier gauge wires to minimize the voltage drop. So great question there again. And we have one final thing. We're at the Minneapolis Home and Landscape Expo at the Metrodome coming up on January 4th and 6th, and again on January 11th and 13th. So if you're local, hey, come on in. If you're, James, is he from England? Hey, fly on in. We'll welcome you with open arms. We'll go out and have a pint down there at the local brew house there. And but if you're one of the many contractors who might be listening to us today, come on in and see the product working, live example of it working right at the show. So on behalf of Andrea and myself here at Heat My Floors, I want to thank you. I want to thank you for staying with us throughout the 4 webinar series. We appreciate your time. We look forward to working with you in the future, and we'll talk to you soon. Good night.